Okay, hi everybody. Yep, coming back to record another video for statistics. So today we have a quite interesting question. Someone was asking me a couple of days ago. It's basically this question. Is there any relationship between, let's say, our regression, I just put it, our linear regression, and let's say one-way ANOVA? Okay. Why? This question is actually quite interesting. Why is that the case? For example, we just have, let's say, a x and y value. Okay, so let me just produce some x value. I use a random, let's say, use a random between, and just have between 10 to 30. Okay, then for the y value, I will just take the original x value and say that I will just randomize somewhere between -2 and 2. Okay, so it should be correlated. Okay, so let me just take a couple of values. And I just paste the values back. The reason why this question comes up is whenever we do a regression, let's say when we do data analysis, we do your regression. Okay. So our y value is here, our x value, and I have the labels and my response, I put it here. Okay. So when I run it, it gives me a ANOVA table. So really, is there any relationship between a regression and ANOVA by itself? Or they are actually the same thing? Okay. So here I will say that, let me put it forward, and I'll say that ANOVA is equals to regression. Okay, put this up. ANOVA is actually equals to regression. Okay, I'll put this up in bold. So we can come back to here again. Bold, capitalize, everything. Okay, huge. Okay, make it even bigger, 20. So ANOVA is equals to regression. Okay, that's my first step. How is that the case? So let's start with some data in itself. So I have 3 samples here. My sample 1, sample 2, sample 3. Okay. So if I were to do it, and we'll just do a one-way ANOVA for itself. So one-way ANOVA is quite easy. The null hypothesis for one-way ANOVA, let's say the null hypothesis for your one-way ANOVA is that average of S1 equals to average of S2 equals to average of S3. Okay, the alternate hypothesis is just, well, they're not the average. So what's wrong with it here? Just get the formatting right. Okay, doesn't matter anyway. So just have this. What the hell does it do? Okay, anyway, you can read it here. Okay, so let's say if you do ANOVA, we just go to our ANOVA one factor, and we have A, B, and C. Labels our first row, and we have output range. So output range, we just leave it here. Oops. Range, just put it this part here, 3. So we have a ANOVA table. Okay, so it is highly significant. So let's think about what on earth are we really doing if we were to convert. What on earth is really ANOVA doing? ANOVA is to test that is the average of S1 equals to average of S2 equals to average of S3. So how does this relate to your regression? So regression, we have to code it in a different way. We have to code it, let's say the data is Y. Okay. And we want to say that whether is it in S1 or whether is it in S2. So indirectly, what we are trying to do is we are using S3 as the reference. So if it's not in S1 and it's not in S2, it'll be in S3. So let's code it this way. Put the tables in. So it is in S1, so we say yes, 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 yes. Is it in S2? No. No, 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 no. Okay. We do the same for the rest. So this will be the opposite. Okay, it's in S2, but it's not in S1. For S3, the sample tree, it is neither in, let me just reduce this a bit. It is neither in sample 1 or sample 2. If it's either in sample 1 or sample 2, then it will be in sample 3. Okay, so we get that clear up. Okay, this is getting on my nerves. Okay, oops. Okay, so what does this really means then? It means that for your regression, so we do our regression here. It means that for our regression in itself, what we are really testing will be something like this. Is we will put the regression model as your Y equals to your beta 0, which is actually the y-intercept, which is technically S3, plus beta 0, beta 1, S1, plus beta 2, S2. So indirectly, what we are trying to ask is, our null hypothesis then is beta 1 equals to beta 2 equals to beta 3, which is technically 0. That's our null hypothesis. So let's run our regression and see what happens. Okay, we go to our regression. Just clear off all this, something in the past. So our Y values will be here. Our X value, S1 and S2. I just call it S1 rather than X. Okay. Then we put our output into, let's say, this cell. And we run it. Voila, what do you see? Do you realize something? This ANOVA table is technically the same as this ANOVA table. Okay, the rows and columns, the columns will be very different, but the result is the same. The F statistic, 22.3, the p-value, which is 0.00031321. Correct? And what is very interesting is, since we are using your S3 as reference, so we are almost like saying that the average, we are almost saying the average of S3 to be equals to 0. So what you end up with is that y-intercept is actually the average of S3. See, this coefficient, these two are the same. These two numbers are the same. Then how do we interpret this? Your S1, which is the coefficient of S1, which is technically coefficient, I'll just retouch right here. coefficient of S1, which is really B1, is technically the average of S1 minus the average of S3. See this? Average of S1 is what? Here, 13.5 minus 25.75. That gives us minus 12.25. Is this value? Let me just show you. In green, this value minus this value, this minus this, you get this, correct? It is 13.5 minus 25.75, you get minus 12.25. Similarly, our coefficient of S2, which is really B2, is technically equals to, I can just say equals, average of S2 minus the average of S3, which is the average of S2, what is it? 18 minus 25.75 equals to minus 7.75. So this is why your ANOVA is technically regression. Just that we code the values differently. In fact, ANOVA and regression are exactly the same thing, which is why you can actually use your regression in place of ANOVA. So this is for one-way ANOVA. You can change it to two-way ANOVA. It works the same way. Okay. So this is the inking point whereby when you do ANOVA and regression, you realize that they're somewhat similar. And what we are really testing is B1, B2 equals B2 equals to B3. Are these values equals to 0? Are these values equal to 0? They are not. Okay, and this is the F statistic. Because why? What we are really testing is the average of these three the average, these three averages equals to itself. Okay, and we use one as a reference, so we minus it off. Okay, so essentially, ANOVA and regression is two sides of the same coin. It can even be ANOVA and regression are identical. Okay, so that's all for today. Hopefully, I can convince you that ANOVA and regression are exactly the same thing. So that's all. Thank you very much.